Good afternoon, everyone. Thank you for being here. In this session, we're going to talk about how you can work with rasters and imageries using Python data. To give you a quick overview, we're going to go through 3 demos today. The first demo is to show you how you can work with raster and the imagery data using ArcPy, how to prepare the data for publish image services. And the second demo is to use ArcPy to automate the workflow you can use to publish image services. Due to the time constraint, we may or may not get into the detail of the third demo. The third demo is about to use the image service REST APIs through Python. If you are interested in the code, just leave me your card here. I will send you the code I'm showing you today. Okay? So let's get started. ArcGIS, it integrates all types of images, from multispectrum, panchromatic, thermal, radar, and satellite. So basically, it supports over 100 native image formats and over 60 sensors. This number is continue growing. So with it, the raster types and the raster products are growing with it. With all these data, what is the recommended way to manage them? So we would recommend users to use Mosaic dataset to manage the data. The Mosaic dataset has to sit inside of a geodatabase. It can be a file geodatabase or an enterprise geodatabase. So if you want to live update your published image service, your data needs to stay in the enterprise geodatabase. So in this demo, I'm using the PostgreSQL database. The Mosaic dataset, it provides a catalog view of your image collection. So it doesn't copy your data into the geodatabase. It just creates a reference to the original data. And you can apply raster functions to your Mosaic dataset. So currently we have over 50 raster functions you can use. You can use them separately or you can chain them together to accomplish more complex tasks. So this Mosaic dataset, they can be shared as image service through image server. So here is a diagram to show you the workflow of automate the imagery management and sharing. So on the left part, it's the data collection part. Once you have the data, you can see the raster types. It sits between your data and the Mosaic dataset. So the raster types is like a pre-cooked template for you to easily add the data into your Mosaic dataset. So it is very specific to the sensor. For example, if you're trying to load the Landsat data, make sure you are using the Landsat raster type. Once you have the Mosaic dataset, you can apply the raster functions to it. These raster functions, they are executed in memory and they generate the on-the-fly result. So it's pretty fast. Once your Mosaic dataset is ready, you can use it in Pro or desktop, or you can publish a service and consume through the web. Okay, let's jump into our first demo. Say I have a folder, it contains data from different type of sensors. And some of the data may not even have a sensor associated. What I'm trying to do is to create Mosaic dataset for each sensor type, and then add data into the Mosaic dataset if it belongs to that sensor type. So to do that, there are a couple of functions I need to use from the ArcPy. So the first one I need to use is the list rasters function. So this will look up the raster data in the workspace. And to categorize the data into different Mosaic datasets, I need to know the sensor name. So I will call this get raster properties management function to return me the sensor name of the raster. And to create the Mosaic dataset and load data, I need to call this create Mosaic dataset management method and add rasters to the Mosaic dataset management method. Okay, so I have wrapped my script into a toolbox. Let's have this tool run, and then we're going to take a close look at the code. So basically, this tool, it takes 2 parameters. One is the input folder, which is the data you want to categorize. So I have this folder. It contains data from different sensors. And I'm going to grab that into this input folder. And then for the output folder, you need to give it a path, and it'll create the Mosaic. It creates a file geodatabase, and within it, it's going to create the Mosaic dataset based on the sensor type. So let it run, and let's take a look at the code. So can you see this clearly? Okay, so the first one, I defined a function, which is the raster finder function. So this function, basically, it calls this list workspace, calls this list rasters function. So it will list the rasters inside of my folder. The get name list function, it will use this get raster properties management function to return me the sensors it has for it contained in these folders. And also this function will return the raster names. And this exclude sensor function, basically what it does is if the raster contains the sensor type, it will remove the raster from the raster list. So that, I'll explain more about this function later. So this load the data function, it will create the Mosaic data set and then add data to it. So here is a for loop. This for loop will loop through each sensor type, and then it calls this create Mosaic data set management and add a raster to Mosaic dataset management to create the Mosaic dataset for each sensor type, and then add the data to it. Within this for loop, we also have this raster list it's calling this exclude sensor function. So when this for loop finishes, this raster list 2 will only contain the rasters that does not have a sensor associated. And we will create a Mosaic dataset for these data, and then use the raster dataset as a raster type to load the data into this Mosaic dataset. So these are main function. These are the 2 parameters we provide, and it calls this get name list to return you the raster name and the sensor type name. And it calls the load data function to create Mosaic dataset and load the data to it. So now it finished running. So here it finds the Landsat data, and it also finds the Iconos data, GeoEye data. And for those data that does not have a sensor type, it creates a Mosaic data set and use the raster data set as the raster type to load the data to it. So, okay. So let's take a look at the result. So this is the GeoEye Mosaic dataset. If you open the attribute table, you can tell from this tag field, it contains the pan-sharpened version of the data and the multispectrum version of the data. And they're all coming from the GeoEye sensor. Okay. So now my rasters has been categorized into different Mosaic dataset based on the sensor type. I want to prepare a Mosaic dataset that I can use to publish image service. So I want this dataset to be created based on my GeoEye data and my Iconos data. I don't want to get everything into my new Mosaic dataset. I just wanted the pan-sharpened version of it to go into the new Mosaic dataset. Also, I want to create a customized field and use the information in the original raster, say wavelengths. I want to populate this new customized field with the wavelengths information. So to do that, I need to do some customization to my Mosaic dataset. One more thing. So this new Mosaic dataset is created based on the 2 Mosaic datasets we generated from the first demo. So we give this new Mosaic dataset a name. It's the derived Mosaic dataset. Basically, it's the Mosaic dataset created based on other Mosaic datasets. So we're going to use the table as the raster type. So to accomplish what I want to do, I need to do some customizations to my Mosaic dataset. To only import the pan-sharpened version of the data, I need to do some customization to the raster type. So let's take a look at this. Add Mosaic to data, add raster to Mosaic dataset too. As you can see, these are the raster types we currently support. And each raster type can be saved as the raster type XML file. So to customize the raster type, you can edit this XML file, or you can go here. There's the auxiliary inputs. This parameter provide you another way to make modification to the raster type. But not all the raster types currently have this aux input available for you to use. So in this demo, the table type, it doesn't have the input, the aux input for you to use. So I have to go through the XML to do the modification. Okay, let's go. And to create the new field and populate with the sensor, with the raster information, I will need to use this get raster properties management and use the ArcPy.da.search cursor to loop through the footprints table. And it will create the raster object from the cursor, and I can read the information from the raster field and get the wavelength information and use that to populate my new field. And there are a lot of geoprocessing tools for Mosaic dataset. All these geoprocessing tools can be used through ArcPy. For example, these auto Mosaic dataset schema or the defined overviews, as long as you have the geoprocessing tool, you can use it in ArcPy. Okay, so for this one, I don't have a toolbox wrapped around it. Let's directly run this code. And then let's take a look. Okay. So for this code, it creates a Mosaic dataset, and then they added this raster type XML file. So basically, it set the restriction to only import the pan-sharpened version of the data. And you can call this add raster to Mosaic dataset management function to add the Mosaic dataset into this derived Mosaic dataset. And you can call this add fields management to create the new field and use this get raster properties management function to return the wavelength information. And you will use this ArcPy.da.search cursor to populate the information for each raster in your Mosaic dataset. So this part is to prepare the Mosaic dataset for live update. Later on, once I publish the data as image service, I want to do live updated to add the Landsat data to it so that you can see the Landsat data will show up in the image service. So to do that, I want to give it this new this derived Mosaic dataset a new boundary by calling this function. And since I want to use the Landsat data, I will call this alter Mosaic dataset schema management function to make this Mosaic dataset be able to host the Landsat data. So the step 4 is some enhancement you can do to display this Mosaic dataset. So I use this define Mosaic dataset node data to define the node data value and use this set Mosaic dataset properties management function to set the Mosaic dataset properties. And you can also build overviews. Okay, so it finished running. This is the connection to my Postgres database. This is where my result has been generated. So let me remove this one and get this one into ArcMap. So if we open this attribute table, you can see all the data here are all the pan-sharpened version of the data. These are some overviews we generated. And the sensor is either GeoEye or Iconos. So now we have data ready to publish. We need to take a couple steps to automate the workflow to publish the image service. So the first step to do it is to create a publisher server connection file to connect to your ArcGIS server. And then you need to create the service definition draft. Once you have the service definition draft, if you want to do some service setting modification, you can change this service definition draft file. And after that, you need to analyze this service definition file, and then you can stage the service definition draft into the service definition file. Once you call this upload service definition function, your image service is published successfully. So there are two ways to publish the image service. One is to publish the service by value, and the other one is to publish by reference. Since we are dealing with large data, we don't recommend the user to publish by value, because that will copy data into your server, which will take too much time and take too much disk space. So to register to publish by reference, all you need to do is to register this data location with your server, to register that as a data store. So this is the code to, let me see. This is the code to publish the image service. Okay, so these are the parameters we provide in the toolbox. And you will call this create GIS server connection file to create the connection file to your ArcGIS server. And then you can call this add data store atom function to register the location with your server. So now your data will be published by reference instead of by a value. And next, you create the image service definition file by calling this function. And here, since I want to use my input as the raster function, so I need to go through this service definition draft to make this change. Basically, I will replace whatever my input is with for this raster function. And you will call this analyze for SD function to analyze this definition draft file. It will return you information about the message, warning, or errors. Next, you will stage this service definition draft into a service definition file by calling the stage service _ server function. Next, you can call this upload service definition server function to publish the image service. So this code has been wrapped into a toolbox as well. So let me open that. So we can provide a server name, username, password, and the Mosaic dataset is the one in my enterprise geo database. Okay, service name, yes, team. Okay, so I want to supply a raster function. I'm gonna supply the NDVI raster function for this service. So it will analyze this and return you this message. So we have 3 warnings. These are not big deal, so missing summary, missing tags. It's okay. Let's take a look at the published service. So this is the image service published from the Mosaic dataset. And you can see the NDVI has applied on the fly. So if you go to these properties and then go to Processing Templates tab, you can choose the raster function you want to apply. I only have one in this demo, but you can have more in real life. So if I choose none to remove the NDVI template, these are the original source data. And if I switch back, so you can see these are pretty fast because this is a raster function they executed in memory. So it doesn't use the geoprocessing tools. So the display is pretty fast. So to access the raster function, you can go to Windows and go to the image analysis. And there is the raster function template editor. You can click on that. Here are the available functions you can use. And you can chain those functions together to make a template, make a raster function chain. Once you are satisfied with your template, you can export it as a template and save it. So this will be saved as the XML file. The one we supplied in the toolbox, that's the NDVI one I saved from here. Okay. So with this image service up running, I want to do a live update. So this is pretty simple. Just add the Landsat data we generated in the first demo to the Mosaic dataset, and it'll show up in your image server. So it's just add a raster to Mosaic dataset. Okay. 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 Now if we come to ArcMap and refresh, you can see the Landsat data has been applied on top of this, has been applied to this Mosaic dataset. And this is the image service, and it can reflect the new data, the new raster we added to the Mosaic dataset. So now we have this image service running, and we can use the image service REST API in Python. So let's see. So from the REST API, you can get the general service information like the spatial reference, the cell size, the pixel type, or the rendering rules. Or you can query individual raster items to get the detailed information of the rasters. Or you can use the export image operation. You can define your area of interest, and you can define your Mosaic rules and define how you want to compress the data. And you can also use different rendering rules. If you have a raster template in this Mosaic data, in this image service, you can choose which raster function you want to use as the rendering rule. Okay. So if you want to know more about what you can do with the REST API, you can check on this link. Okay. So this is a code sample to use the API for to use the REST API in Python. So Python has a couple models that you can use to do this request for request. You can use URL lib2, or you can use requests. So when you install ArcGIS product, the request model has been installed with by default. So for this demo, as you can see, you need to first construct the post body. This is the bounding box, the pixel size, the image spatial reference, the bounding box spatial reference, and etc. So once you have your body construct, you can call this request.post function to send the request to your image server. And your image server will process this request and then return you the URL that contains the image that you requested. And then you can call this request.post or request.get function to send the request to get the actual image you requested. and read it to your local folder or local drive. So that's basically the download process. Okay, so I don't think we have time to go through detail of this script, but let me show you this quickly what this script can do. So if you open this toolbox, select the raster layer and give it output folder. And you can select the area interest. And I'm going to use the default raster function. So this is the one with the NDVI one we published. So this is the result. Okay. All right. Okay, so that's basically it. And do we have any questions? Thank you.
Yeah, is there code to delete an image service?
To delete image service through Python, right?
Yes.
Yes, right? Wait.
Okay, so the question is about whether there's a capability to delete an image service. Yes, so the image service REST API contain a delete operation. Yeah, so you can, so basically through Python, calling the REST API is similar as what she shows here. If you look up the delete operation on the image service, you can just make the same post request through the request library to delete the service. It's definitely doable, yes.
Okay, thank you.
Okay.